Good evening, guys. It has been a long time that I could not upload any videos. Apologies for that as I was caught up in something. I hope you all are keeping safe, staying at home, and studying. Please take very good care of your health, your people around you, and follow all the COVID norms. Today, I'll take up a lecture on jet streams. As I had already mentioned in my Telegram channel also and the group that uh, I had uploaded a video on Coriolis force and the atmospheric circulation of the Earth. I am sure all of you must have watched that. And of course, there are several other very good videos on YouTube and very nice study material from which you can understand a lot about the uh, atmospheric circulation and Coriolis effect. So, today we are going to take up another topic, jet streams. It's a very important type of wind patterns which blow up in the upper atmosphere, and they are very significant for the weather patterns. So let us see how the jet streams originate, what are their characteristic features. So jet streams are swift geostrophic air streams in the upper troposphere. Geostrophic air streams. So basically these are the geostrophic currents which run in the upper troposphere. The pressure at which the jet streams they function is 250 hectopascal, that is one fourth of one atmosphere, so one fourth atmosphere. The height of jet streams, it varies from 8 to 12 kilometers at the poles and 10 to 16 kilometers at subtropical latitudes. So why does this happen? Because the jet streams they operate at tropopause, and the height of tropopause it varies. Height of tropopause varies as we go from equator towards the poles. So at the poles, the tropopause is at a lower height in relation to the height of tropopause at the equator. So therefore, the jet streams they are lower in height at the poles while they are higher in height at the subtropical or lower latitudes. The jet streams they are very fast moving and they may have a velocity of up to 400 to 500 kilometers per hour, very fast moving, and they follow a meandering path. We will see why the jet streams meander. Very important features which control the jet streams are the temperature and pressure gradient along with the Coriolis effect. The jet streams they are circumpolar in character. So you all must be knowing what is circumpolar means. If let us say this is the earth, this is the northern hemisphere, this is the pole. So the jet streams they encircle the entire poles. That is why they are called as circumpolar. So they do a round of the entire globe. Sometimes the continents influence the jet streams and deviate them from their path. So that is why many a time you will see that the jet streams when they operate, they show a lot of bending and they deviate from their path which goes from west to east. So we'll also see why they move from west to east. Jet streams are also characterized by a great seasonal variation. So when we say the great seasonal variation, it means we are talking about the solar input, the pressure gradient, etc. So with seasons, the jet streams also vary. During colder part of the year, they migrate towards equator and their velocity is very high. We'll see that when it is the cooler season, then the jet streams they migrate towards the equator, means their sinuosity or their waves which are formed, they are bending towards the equator, and their velocity is very, very high. Always remember that the jet streams, they have higher velocity during the winter season because of the higher temperature gradient. During the summer seasons, the temperature gradient is not as high as during the winter season. Therefore, the jet streams during the winter season have higher velocity. Jet streams are stronger in winter in the northern and southern hemispheres because that's when the air temperature difference that drives them tends to be more pronounced. So this is what I was talking about, the air temperature difference, or we can say the temperature gradient. And of course, the jet streams, they always are changing, moving to higher or lower latitudes. They break up, shift in the flow, and they depend on seasons and other variables. So uh, we will now discuss in detail about the jet streams. A very simple thing is that the jet streams, they are westerly winds. Always remember that when we talk about the wind direction, we have to keep in mind one thing, that the winds are named for the direction from which they ब्लो, मतलब जिस डायरेक्शन से विंड्स चलती हैं वही उसका नाम होता है। जैसे अगर कोई विंड वेस्ट से आ रही है तो उसका नाम होगा वेस्टर्ली विंड। सो जाहिर सी बात है कि वेस्ट वेस्ट से आ रही विंड वो ईस्ट की तरफ जाएगी। सो अ वेस्टर्ली विंड हैज अ डायरेक्शन फ्रॉम वेस्ट टू ईस्ट, while an easterly wind easterly wind has a direction from east to west. So the jet streams, they are westerly winds, means they move from west towards east. Now, this is the case for the entire globe. So in both the hemispheres, northern hemisphere and southern hemisphere, the jet streams, they flow in the uh, direction from west to east. Now, if we see these three diagrams which are given over here, so in my video where I have explained the Coriolis effect, I had mentioned an important thing, that the velocity of the Earth, that is the angular velocity of the Earth at different latitudes, is different. So there, the equator is moving at a very fast speed, and then as we go from equator towards the pole in in both the hemispheres, the velocity of the Earth, or that latitude particularly, goes on decreasing, and at the poles it is almost zero. So the movement of the any entity, if it is an air mass, if it happens from the if it goes from the equator towards the pole, it will maintain its angular momentum, and due to that angular momentum conservation, the object seems to get deflected. Say for example, I'll show you. Let us suppose that this is equator, and an object, or let us say an air mass, is going from equator towards the pole. Now, this air mass will have an eastward component, and that angular momentum will be conserved. So, if the air mass is reaching this latitude, which is, let us say, sorry, wait, let me, yeah, let us say that a particular air mass is reaching, is moving at the equator, and from here it is going towards the poles. Now what has happened is that the speed of this latitude is less than equator, speed of this latitude is less than this latitude, the previous one. So as we keep on moving towards higher latitudes, the speed progressively decreases. As a result, you will see that due to this conservation of angular momentum, that air mass seems to get deflected towards east. So you will find as if that the wind is coming from this direction to this direction, that this deflection. So this deflection is because of the Coriolis effect. Okay. If you want to know more about it, there are a lot of material. I have a video also on this. You can read. If you have any doubt, you can let me know. So we just saw that due to Coriolis effect, the winds under the impact of conservation of angular momentum have the direction of west to east. And we, of course, we all know that the earth, it rotates from west to east. Okay. All right. So how these jet streams are formed? Jet streams can be classified into two types: the subtropical jet streams and the polar jet streams. Now in the very beginning I had told you that the jet streams, they flow in the upper atmosphere, so at the tropopause. And we all know that there are three types of circulation cells: the Hadley cell, Ferrel cell, and polar cell. The Hadley cell, if we do a quick recap, the Hadley cell has its rising arm at the equator. It reaches the tropopause and diverges in both the hemisphere, reaches 30-degree latitude, and there it starts sinking, that is called the sinking arm. And then the air, as it hits the surface of the earth, it then diverges again. One arm, the returning arm, it goes towards equator and completes the Hadley cell, while the other arm, which goes towards 60-degree north latitude or 60-degree south latitude, it forms the forward moving arm of the Ferrel cell. Then the cold air coming from the poles, which comes to the 60-degree north latitude, is very low in temperature and quite heavy, denser. So the buoyancy over there, it causes the air from the 30-degree north or south latitude to push up, and then it becomes the rising arm of the Ferrel cell. So this Ferrel cell completes its circulation, and then as it hits the tropopause, some part of it gets diverges towards the poles also. That is how we get the three circulation cells. So an interesting fact over here is that at 30-degree north latitudes, the Hadley cell and Ferrel cell meet, while at 60-degree north and south latitude, the Ferrel cell and polar cells, they meet. So in the first case, where the Hadley cell and Ferrel cell, they meet, there the air is sinking. So here, where they both meet, the air sinks, while where the Ferrel cell and polar cell meet, the air rises. And an interesting fact over here is, if you see this diagram carefully, this diagram is taken from Wikipedia. If you see this carefully, you will find that the air which is coming from equator towards 30-degree latitude has a higher temperature than the air coming from 60-degree to towards 30-degree latitude. So temperature of Hadley cell air is more than temperature of Ferrel cell air. It means that we have two air masses which are of different temperature, different characteristics. So these air masses, they don't mix properly. Similarly, if we look at the Ferrel cell and the polar cell, In the Ferrel cell, and the two cells, they meet at 60° north latitude. Again, the temperature of air, sorry, the temperature of air, sorry for that glitch, the temperature of air at the Ferrel cell will definitely be more than the temperature of air coming from the polar cell. So here again we have cells from two different we have two different air masses, and therefore these two different air masses, they don't mix properly. So again here we have different sets of air masses. Now what will let us see what will happen. Let me draw for you this diagram. So this is equator, 10, 20, 30, 40, 50, 60, and then this is 90°. Similarly for the southern hemisphere. So what will happen over here? And let us say this is the tropopause. All right. Now, as the air rises up from over here, from the equator, it hits the tropopause, diverges, and then sinks at 30° latitude and then comes back. Okay. This air which hits the surface of the earth either goes back towards the equator, or it moves forward towards 60° latitude. As a result, we get a void or a space at the junction of these two air masses. Same, same way, from the poles, the cooler air mass, it comes up towards 60° latitude. This air mass, which is coming from 90° latitude, pushes the air from the 30° latitude up. So we get the polar front over here. So let me draw for you the polar front. So this zone over here, this is the polar front. Now, when this happens, again, these two air masses, once they rise, they do not mix properly, and then here again this air is trapped in the upper atmosphere. As they hit the tropopause, some part of it comes back, other goes back towards the poles. So this is how we get the uh, three cells. Now the air mass which is here in the voids at the junction of these two cells, they start moving towards east from west. So if we try to draw this, then we will see that this air mass over here and this air mass over here, they will be set into motion, and so we will get winds which are moving from west towards east. Now they, interestingly, they will be concentrated only in two zones, the 30° latitude, that is the subtropical latitude, and then over here at the polar latitudes. So these two, they together form the jet streams, and thus we get two types of jets. This is called as subtropical jets, while These are the polar jets. Okay, I hope this diagram you understood. So if we see this in cross section, let me draw for you first the tropopause. So tropopause is higher at the equator and lower at the poles. That is how I have schematically drawn it. So this is tropopause, TP. So this is equator, then 10, 20, 30, 40, 50, 60, 70, 80, and this is 90 over here, the south pole, and then 10, 20, 30, 40, 50, 60, 70, 80, and 90 north pole. So let me quickly draw the three cells. All right. Okay. So if we see over here, same way as we saw in the previous slide. So the Hadley cell, Ferrel cell, and this is the polar cell, Hadley cell, Ferrel cell, and the polar cell. So where Hadley cell and polar cell they converge, this is one of the locations where the uh, jet streams they originate, and the second one is where Ferrel cell and polar cells converge. This is the location where the uh, jet streams they originate. So if let us quickly draw those places where the jet streams they originate in this map, and then over here 30. So this wind which is trapped in this tropopause due to the convergence or due to the meeting of these two cells, but due to the different properties of the two air masses, these winds are unable to mix up properly, and therefore some amount of air is trapped which starts moving at a very fast speed. And how do they look like? So one is this way. This is how one, and then the other one which is at the poles. And in both, so I'll draw the broad arrows so that you can understand the direction of movement. And similarly over here, and then over here. And in both the cases, so in both the hemispheres, we find the jet streams, and they are the subtropical jets, which is this one, S T J, S T J, and the polar jet streams, PJ. Okay, so I hope you understood how these jet streams are formed. So basically here you have to keep in mind a few things, that jet streams they originate where two wind circulation cells they converge or they meet, and the different temperature conditions of the air masses does not allow them to mix up properly. As a result, in the tropopause, some air remains trapped. It starts moving under the impact of Coriolis force from west to east. They are very, very fast moving winds, and thus they form the jet streams. So the jet streams, as they start moving, they have these four indices. So this is called as the index cycle of the jet streams. The high zonal index is the one in the which is the initial phase of jet streams. So the first stage, the jet streams, they are quite close to the polar regions, and of course they flow from west to east. So the jet streams, they are very close to the polar region. So if this is the polar region over here, if this is the polar region over here, they are very close or in the vicinity of the jet streams. Then in the northern hemisphere, the cold air mass is found to the north of these winds. The cold air mass, so this will be the cold air mass in the northern hemisphere, while the warmer air mass will be towards the south of these winds. And it shows a lot of cyclonic activity over here. The air mass exchange between the temperate and tropical regions in this case is very, very less. This is called as the high zonal index. In the second stage, in the second index, what happens is that the winds, they start moving towards the equator. So you can see these wave-like patterns. Now it has started moving towards equator. As a result, lot of this cold air mass, it starts shifting towards the southern part of the hemisphere. Now the warm air mass, it starts moving toward the higher latitude, while cold air mass starts moving towards the lower latitude. So here this is the extension towards the equator. Next, in the next stage, the third stage, the bends, they become very sharp. So they are sharper bends. Now we can see over here that as these cold and warm air mass start pushing the winds towards the equator or away from the equator, then this jet streams, they start to meander now. They're just like a meandering river. The jet streams, they start to meander. Here, the bend in the jet streams becomes sharper and amplitude of the waves registers a further increase. So the wave amplitude in the third index, wave amplitude increases. Amplitude increases over here. At this stage, the tropical air masses move further north. Now, the warm air mass, it has moved very close to very high latitudes, while the cold air mass, it has come very close to the lower latitude. This is only because of the extreme meandering shape. And the jet stream is positioned near the equator, and the exchange of tropical and polar air masses takes place on a much larger scale. And the last part of this last stage of index is that these giant meanders, sometimes they break off. So if I give you the example of a river, meandering river, if this is the initial phase of river, then river starts to meander more, and then this loop becomes very, very strong for the meandering river, and then finally this river straightens itself, leaving behind an oxbow lake. Similarly, the jet streams, in their last stage, what do? They do that sometimes they break off from the main stream. So you can see here that these these eddy like patterns are formed because they have broken from the main jet stream. So they get broken off from the main jet streams, and then they are isolated. The result is that an uh, a very big pool of cold and dense polar air is isolated in the upper troposphere of the lower latitude. So you can see here that this was the cold air mass. It has broken down from the mainstream. It gets trapped in the tropopause of the lower latitude regions. And in the upper atmosphere of higher latitudes, this warm air mass, warm or the tropical air mass, it gets trapped up. So this is called as the low zonal index. This is the name given to the index cycle of jet stream. So here in these four stages, the first stage, that is the high zonal index, is very simple, where the jet streams simply flow parallel to the latitude. Here till now you will not be able to see the uh, bending or meandering patterns. Then in the second stage, the uh, jet streams start to show little bend or start meandering slowly. In the third stage, the bends, they become very sharp and a wave amplitude increases. While in the fourth case, the eddies are formed, or the pools of cold and warm air are formed because they break off from the mainstream. As these waves are formed in the jet streams, so these jet streams are normally horizontally moving winds, and these waves which are formed, they are called as Rossby waves. So remember this, that these Rossby waves are the waves which are formed when the jet streams starts to meander. So I hope it is clear. So if we look at the cross section of a jet stream, the strength of the of the winds increases towards the core of the jet stream. So if this is the core of the jet stream, it will have the highest wind velocity, followed by decreasing wind velocities as we go towards the periphery of the jet streams. And then it also does not reside at any one particular height, but can extend across hundreds of miles wide and thousands of feet in height. So the jet streams, they are fast moving, they are quite wide, and then they are very, very long. So as we have just seen that they are circumpolar, means they encircle the entire globe, it means that they have to be longer. So one way of visualizing this is to consider a river. The river current is generally strongest in the center. So let us say that this is a meandering river channel, and this is the flow of water. So this will be the zone where the water velocity will be highest. So this is the highest velocity, followed by a decrease towards the river banks. Similarly, you can see here that in the center or the core, the winds of jet streams, they have highest velocity, followed by the decrease in velocity as you go towards the periphery. Therefore, jet streams are also called as rivers of air. So sometimes if a question is asked in section B of uh, net exam or any competitive exam, which winds are also called as rivers of air, then you have to answer it as jet streams. Now let us look at this small video. I have downloaded it from the earth.nullschool.net. You can see that this is in this map, you can see these meandering patterns which are blowing in the upper atmosphere. Okay, now you can see here how these winds, they are completing their journey for the entire globe. So you can see over here that there are extreme meandering patterns. These are the polar jet streams, while these are, which are in the subtropical regions, they are the subtropical jets. Let me play this video once more for you, and then you will see a very interesting pattern over here. The polar jet streams and the subtropical jet streams. So if you see over here, you will see that the polar jet streams, they are showing very sharp bends or very sharp meandering loops in the northern hemisphere, while in the southern hemisphere, these bends are not as sharper as in the northern hemisphere. In the southern hemisphere, we can see relatively straighter winds. So why does this happen? This happens because the northern hemisphere has lot of land mass portion or continental portion, and the variation in the specific heat capacity of the land and oceans, it causes a steep temperature gradient. As a result, the meandering pattern is more pronounced in the northern hemisphere, while in southern hemisphere, which is also called as water hemisphere, we have very less amount of land masses, and therefore you can see that the bend of the jet streams is, or meander of jet streams are not as sharp in the southern hemisphere as in the northern hemisphere. Let us look at one more video where you will find that how the circumpolar feature of wind looks like. So you can see here, this is the North Pole. Let me just stop the video. So this is the Arctic region. You can see Greenland, the Canadian Iceland area and all. So this is the North Pole. You can see that the winds, the jet streams, they are encircling the entire North Pole. Let us see this video. That is why they are called as circumpolar. And if you start counting the waves over here, they are so long, the jet streams are so long that within 6 or 7 waves, the entire poles are in circles. Now you are looking at the Antarctica, the South Pole. So in both the cases, you saw that the North Pole and South Pole, they are completely encircled. So this is the North Pole, which is getting encircled by the uh, jet streams, while the South Pole, which is also being encircled by the jet streams. So this proves our point that the jet streams, they are circumpolar. Okay. Apart from these major, so the polar jet streams, they are the major jet streams. So whenever we say polar jet streams, then they are the main jet streams. Polar jets, they are the main. When I say main, what does it mean? Because of the fast moving velocity. So we all know that the jet streams, they have very high velocities, and the polar ones are the actual jet streams which are really blowing at a very high speed, while the subtropical jet streams, they have a velocity lower than the polar jet streams. Apart from these, important global jet streams, we have few local jet streams as well. Two of them are very important. First one is the Somali jet, and second one is the tropical easterly jet. Now, the Somali jet, it is near the African coast, near Somalia. They are also known as find later jets. Find later was a scientist who discovered these winds in 1960s or 70s, and in his honor, the Somali jet streams are also called as find later jets. While the second one is interesting, tropical easterly jet. Till now we saw that the jet streams, they are westerly winds. So what happened over here, that these winds, they became easterly. When I say easterly, it means that the tropical easterly jets, they move from east towards west. So now here the direction has changed. So let us see how they are formed. The Somali jets, this is the reason where Somali jets, they blow from. Okay, the find later jets or Somali jets. Somali jet. Now, during the uh, summer months of the northern hemisphere, that is the months of May, June, July, they are the winter months for the southern hemisphere. This is what you all know, and I've also told you about this, that the northern summer months or summer months of northern hemisphere, May, June, July, are the winter months for southern hemisphere. So once these months are uh, during the during these months of the year, in the southern hemisphere, the Australian landmass, it cools very quickly. As a result, it develops a high pressure zone, and The surrounding Indian Ocean, it has a low pressure zone. As a result, the winds, they get directed from the Australian landmass towards African continent. So these are the southeasterly winds. So they blow from southeast and go towards the western part. In this region, in this region, flows a current, an ocean current, which is known as the Somali current. Somali current is a very interesting current. Somali current, it is a reversible ocean current. It changes its direction during the summer and winter months. So what, and this is a warm current. So what happens over here? The southeast winds coming from Australia, they come over here, and then as they cross the equator, these winds, they turn towards right under the impact of Coriolis force. So here, as they cross these uh, equator, they turn right, and then their direction becomes southwest. I hope you understood that during the summer months, during the summer months, which are winter months for southern hemisphere, what happens is that the Australian landmass is very, very cold. As a result, it develops high pressure zone. The Indian Ocean surrounding Australia has low pressure zone. Winds start moving from Australian landmass over the Indian Ocean. As these winds, they cross the equator, they turn right under the impact of Coriolis force, and they become southwesterly winds. At this time, when these winds, they become southwesterly winds, then they drag the ocean current, which is the Somali current, over here. If I And the Somali current, under the impact of these winds, it reverses its direction and starts moving towards north. Earlier, it was moving towards south, now it starts moving towards north. This is a warm ocean current. It increases the temperature over here of the ocean, and thus from this island of Socotra near Somalia region of Africa, these winds, they get generated, and then they are called as the Somali jets or fine later jets, and they strengthen the Indian monsoon. This is how these Somali jets, they get generated. Now let us talk about the tropical easterly jets. Tropical easterly jets are formed near Tibetan region over here, Tibet. We all know that the Tibetan plateau is, it is a pan-like in shape. It is a plateau, and during the summer months, it heats up. It becomes very, very hot. As a result, the winds over here, they start to rise. Okay, and already the subtropical jets, they are moving in this direction. So this is subtropical jets, they are moving in this direction. As a result, what happens is that the winds or the air which was rising over Tibet, it starts encircling it, you know, this motion. And thus, this wind now starts moving in this direction from east towards west. And of course, under the impact of Coriolis force, it turns again southwest. So what happens over here is that the Tibetan plateau, it heats up during summer months, causes the air to rise. That air mass, under the influence of subtropical jet streams, it turns right and then goes from east towards west, forming the tropical easterly jet streams. So we can see here that both these jet streams, the Somali jets or fine later jets and the tropical easterly jets. They are very useful for the Indian summer monsoon as they strengthen the southwest monsoonal winds. So these are the few local jet streams. So coming to the last point, what is the significance of jet streams? So jet streams, they exert immense influence on daily weather conditions. When they are placed above temperate cyclones, its intensity increases. Jet streams bring about horizontal convergence and divergence in the upper troposphere. Surface weather conditions also undergo changes owing to the presence of jet streams, which again influences the form and nature of ground surface cyclones and anticyclones. So this is in nutshell about jet streams. If you want to read more about it, of course, you should read D.S. Lal. Plus, there are several other lot of material on jet streams, but there are a few very good videos on YouTube about jet streams. Most of them have covered some topic or the other, and if you wish to study in detail about jet streams, then I think I have covered a lot of it. But still, you can go about reading it, and if you have any doubts, you are welcome to clarify your doubts. So I am sure you must have enjoyed this video. Thank you very much.